Hello, this is Emily Banks here, and I'm going to talk about my Module 5 assignment. I thought about creating a flashlight with my students that they could use during our Flashlight Friday time. During this time, we turn the lights off and we read with flashlights a book of their choice. And they actually really like it, it's really fun for them. So I started thinking about this process using the engineering design process. I began to ask, what materials should I use? How can I use these materials? How can I use this circuit board to create a flashlight? Am I going to need any additional materials? Is this light going to be bright enough so my students can see for the Flashlight Friday? All of this goes under what Vasquez says about it begins with a question and seeks to develop testable answers to these questions, which is exactly what I did. Next, I went to the Imagine stage, which Vasquez says the Imagine stage is for making predictions that can be tested. Therefore, I started to imagine and brainstorm how I could use materials to create a flashlight. I looked up different examples of flashlights and circuit boards on the internet to gain some background knowledge. And I learned how the circuits need to be closed, the definition of circuits, how they conduct electricity, and how flashlights need to be powered by electricity. And then I went to the planning stage, which Vasquez defines as determining materials, identifying variables, defining conditions to examine, and determine how these results are going to be recorded. I started to plan out my design. I was thinking, where should I start? Am I going to need any additional materials? Will my lights be bright enough for my kids to use these flashlights? Am I going to have to buy any more resources? What can I use as a base for this flashlight? So I started to gather my materials, which brought me to the create stage. On the left, you can see my materials. In the middle, I ended up taking 2 pieces of Play-Doh and put them around a white little barrier here, which is used to close the circuit. And I placed the one red wire inside of the green Play-Doh and the black wire inside of the blue. And at first, when I turned it on, it didn't work. So I found out that it brought me to the improved stage that I must have short-circuited the light bulbs when I was trying to play with these and put them in, because I think I broke a few of them. Next, I tried a different light bulb, and as you can see, it worked that time. So now that I have my base, I needed to figure out how I'm going to put this in a flashlight form, which led me to getting this plastic cup. I cut a hole out of the bottom. I stuck the entire thing inside of the plastic cup, as you can see in the pictures. And then I turned on the light and it still worked, so I knew I was good. I needed to figure out how I could kind of make this more flashlight-like, and I ended up taping the bottom of the circuit board to the cup to kind of create like a handle, and as you can see, I could use it to see. The Rich Task Planning figure 6.4, I said it was in order for students to create an electrical circuit, instead of asking them to complete a worksheet or showing the circuit process, try inviting them to design a tool using the Squishy Circuits kit. In this case, we did flashlights. In my design tool 5.1, you can see that I gave it all of 2s. I thought the lesson was problem solving. It relates to the students. It allows for multiple and creative approaches. It integrates science and math content that is grade level standards. It's clear. It uses the engineering design process. It lets the students do the hands-on learning approach. It leads to development of a model. It's a role of technology I have included in my lesson plan that you can check out. The lesson successfully engages the students in teamwork, and it allows them to create a solution evaluating the results. And the lesson also involves students communicating their design. And last, here's my lesson plan that you can look at as attached. Thank you.